ABCD is a quadrilateral in which AB ABCD. AD is BC. Then EFGH are the midpoints of AB, BD, CD and AC. So E is the midpoint of AB, E, the F is the midpoint of BD. So we have to join the diagonal. F midpoint of BD. Then G midpoint of CD. And H midpoint of AC. Then prove that EFGH is a rhombus. So we will join EFGH. See, we have to put EFGH is a rhombus. Now you are given AD is equal to BC. Now, since there are some midpoints, we will indicate them. See, E is the midpoint of AB, so AE is EB. Then F is the midpoint of DB, so DF is FB. Then H is the midpoint of AC, hence AH is HC. G is the midpoint of BC, so DG is GC. Okay? Now, let us take up this triangle ABD. In triangle ABD, we have E as the midpoint of AB and F as the midpoint of BB. So, if you join EF, we know EF is parallel to AD and EF is half of AD. Okay, so EF is parallel to AD and EF is half of AD. Then let us consider the other triangle which has HG as a segment inside. See, you take triangle ACD. Triangle ACD. Now, in triangle ACD, H is the midpoint of AC, G is the midpoint of DC. So, joining H and G, we will have HG parallel to AD and HG half of AD. So, in triangle ACD, HG is parallel to AD, so mark it as relation 3, and HG is half of AD, mark it as relation 4. Now, let us compare the different expressions which are marked as 1, 2, 3 and 4. See, you take up 1, we have EF parallel to AD, then take up 3, we have HG parallel to AD. So, EF is parallel to AD and HG is parallel to AD. So, combining the two, we have EF being parallel to HG. So, from condition 1 and 3, we have EF parallel to AD, parallel to HG, that implies EF is parallel to HG. Then, now let us compare the second condition with the fourth condition. In the second condition, we have EF equals half of AD. In the fourth condition, HG equals half of AD. That means EF and HG are equal. So, from 2 and 3, 2 and 4, we have EF equals HG equals half AD. Now, when you look into these two conditions, see, EF is parallel to HG and EF is equal to HG. See, we have EF is parallel to HG and EF is equal to HG. So, when you take EFGH as a quadrilateral, first of all, you consider EFGH as a quadrilateral. In this quadrilateral, we have got one pair of opposite sides, that is EF and HG are parallel and equal. Then, that implies that EFGH is a parallelogram. So, now we have concluded that EFGH is a parallelogram. It is a parallelogram. See, now we have to prove that it is a rhombus. See, we have to prove EFGH is a rhombus. So we have already proved it is a parallelogram. Now, what is the condition for a parallelogram to become a rhombus? If we can prove EF and EH are equal, that is, the adjacent sides are equal. If we can prove the adjacent sides are equal in a parallelogram, that implies that the parallelogram is a rhombus. Okay. Now, let us take up the triangle which contains EH as a segment inside. So that is, you take triangle ABC. In ABC triangle, E is the midpoint of AB, H is the midpoint of AC. So, EH will be half of BC. Okay, so this is the idea we are going to make use of. So, in triangle ABC, in triangle ABC, we have EH equals half BC. EH is half BC. But then you may see, according to the data, BC is equal to AD. BC is given to be AD, so I am going to replace BC by AD. So I will write half of, instead of BC, AD. But see, we have proved one particular segment to be equal to half AD. What is it? See, EF. EF is equal to half AD. So, from the second condition, I am going to replace the half AD by EF. So, it is EF from 2. Right. See, now let us club these two. We have EH equals EF. See, you may notice in the picture, EF is EH. We have already proved EFGH is a parallelogram in which the adjacent sides EF and EH are equal. So, EFGH is a rhombus. EFGH is a rhombus.